Okay, this is not easy. You got to think of the logic behind it, okay? So rewrite this chemical equation, including the energy, as a term in the balanced chemical equation. So that means plugging it in to the middle of the A plus B plus C. So here I've rewritten it as it is. Then if it's negative, it means the chemicals have lost energy. It's exothermic. The energy has been produced, so it's a product. If I keep the balancing the same, the number's the same. Happy so far?
Yeah.
Okay. So then this one, what's the molar enthalpy? What does that molar enthalpy bit mean?
The amount of energy lost.
For 1 mole.
Oh, okay.
1 mole. Molar enthalpy. So my answer is going to be in kilojoules per mole. Of the iron 2 sulfide. So the iron 2 sulfide at the moment is how many moles? Not 1 mole, but 4 moles. So 4 moles reacted, and how much energy do those 4 moles give me? 2,456 kilojoules. Negative, meaning it exothermic. So how much should 1 mole give me? Pardon me, Nick? 614. Negative 614 kilojoules per mole. Dividing by 4, not because we always divide, not because your friend divided, but because if I had 4 moles, give me 2,000, then 1 mole gives me 500. Okay? The molar enthalpy of iron 3 oxide. So here I've got 2 moles of iron 3 oxide gave me negative 2,456 kilojoules. So how much should 1 mole give me? Well, if 2 gave me 2,400, then 1 mole should give me 1,200, right? So 1, 2, 25, and 3 is 28. Kilojoules per mole. My answer should be kilojoules per mole, yeah? If you've got your answers in kilojoules per mole for units. Good. Now I want to make a point of a conversation we had back here. Why can't you look these up in the data booklet?
Different reactions.
It's a different reaction. What reaction's in your data booklet? Formation. And so if I look up iron 2 sulfide in my data booklet, I'm looking up iron plus sulfur, iron 2 sulfide. And how much energy does that take? Or we don't put energy anymore, but we put delta H. Okay? And this, how much energy do you put out in chemistry class versus how much energy you put out in PE class is very different. They are different reactions. You get different amount of energy. So you can't just use this and apply it here when it's talking about this. Okay? You can't just say, well, I output 1,000 kilojoules of energy in chemistry, therefore it must be the same in gym class. No, it's not. Of course not. And if you undergo 4 gym classes and you get this much energy, how much do you get out for 1 gym class? Make sense? You've got to use your logic all the way through, and then you know whether to divide or multiply. Okay, so have a go at 2 and 3, and I'll put the answers on the board later.